All right, welcome back. I hope you all are doing well and did well on your test earlier today or yesterday, depending on when you're watching this. Go ahead and pause this and do your warm-up. And I'm going to keep moving on here. So, Chapter 2 is all about scientific notation, which some of you have probably done in science class. I think most of you have. So we're just going to do a little stint on this. I talked to Mr. Slate and he said you guys could use some more practice on it. So we'll go with this. And also I printed off the guided notes for you, so if you pull that up, you'll kind of see typed what I'm saying, a little bit more specific. So just like last week, we've been talking all about exponents. So just like with exponents, scientific notation helps us to write very large or very small numbers into a more manageable piece. So when you're talking about 300 billion miles away, we can write that in a little bit smaller bit of a number. So just an example of that scientific notation, even though I'm pretty sure all of you guys know this. If I look at this number, I can write this as 3 times 10 to the 8th power, because I have 1, 2, 3, 4, 5, 6, 7, 8 places before that 3. So this would be 3 times 10 to the 8th power. Okay. So just to recall, when you're writing a number in scientific notation, the number in front, so this number here, is called the coefficient. Okay, and that phrase is actually typed for you in the notes already. So the number in front, I'm sorry, it's this number, not this number here. The number in front of the 10 power, that's called the coefficient. And as you just did in your warm-up, the 10 is the base number, and the 8 is the exponent power. Okay. And then remember, when you write a number in scientific notation, the coefficient, oh, there's two F's, sorry. Forgot an I in there. Must be between the numbers 1 and 9. So this number right here can't be 0, and it can't be 10, 11, 12, or anything bigger than that. Okay, it has to be the number between 1 and 9. So that's the number in front of the decimal place as well, okay? Just that number. So let's see what numbers are written correctly in scientific notation. So these examples, you're supposed to identify which ones are properly written in scientific notation. So a horse chestnut has a diameter of 2 times 10 to the 0 centimeters. So is 2 times 10 to the 0, I'm sorry, written properly? And it is, because this number, the coefficient, is between 1 and 9, I'm sorry, and it's 10 to some power. So this is yes. B, Neptune is about 4.488 times 10 to the 9th kilometers from the sun. And they want to know if 4.488 times 10 to the 9th is properly written. Oops, sorry, you guys can't see all that. In scientific notation, and that is a yes, because my coefficient is between 1 and 9. And that's this number here. This whole number is called the coefficient, but I only care about the number in front of the decimal being between 1 and 9. And then it's times 10 to some power. It doesn't matter if the power is positive or negative. Letter C here is the approximate wavelength of infrared light is 0.01 times 10 to the negative 5 meters, or meter in this case. So this number here, the 0.01 times 10 to the negative 5, is not written in proper scientific notation because the coefficient is not written as a number between 1 and 9. Okay, so this number here, I'll do it in a different color. My pens are covered up by my notebook, sorry. That number there has to be between 1 and 9, so that's my problem area. then we're going to keep on cruising here. Whoops, you guys can't see the edge of my paper there. So D, I'll keep writing in black here. Okay, the last example that I have on your sheet there is a football field, excluding the end zones, is 10 times 10 to the 1 yards long. And again, take a guess here, is that properly written in scientific notation? And that's going to be no. Again, because that coefficient is not between 1 and 9, just like in the last problem. Okay. So make sure you understand how to properly write something in scientific notation. The next little thing we're going to do is properly writing a number in scientific notation. Okay. So if I give you, so my instruction is to write in scientific notation. So if I look at A, it's 427.7. I want to write that in scientific notation. Now, some of you probably learn a couple different ways. So I want the number in front of my decimal to be between between 1 and 9. So this first number 4, if I move my decimal to right there, that means it would be between 1 and 9. So I'm really moving my decimal to the left 2 spots. So that means in order to get back to the 427, I'm multiplying by 100. So this would be 4.277 times 100. Okay, which means 100 is really 10 squared. So this would now be written in proper scientific notation. The way I do it when I'm actually working through some of these problems is, give myself some room here. So you can do this either way. Oops. So I'm starting with 427.7. I say, well, 1 decimal place, that's 42. That's not between 1 and 9. 2 decimal places, 4 is now between 1 and 9. So I moved 2 places this way. Okay. And since I made a bigger number smaller, I went from 427 to 4.27, that means my exponent is positive. So it's kind of backwards. Even though I'm moving towards the negative, my exponent is positive. And since I moved 2 spots, my exponent's 2 with a base power of 10, because all of my base powers are 10 with scientific notation. And now I can write my whole decimal place here. Okay. So 2 kind of ways to think about it. And this might be your own personal preference. If you learned it slightly different in science class and you prefer that method, that is fine with me. Okay, as long as you're getting the right answer consistently. Okay. So now let's look at a different example. I have 0.007. Again, this number right in front of my coefficient here is not between 1 and 9. So I'm going to move my decimal place until it is. If I move it here, that's still 0. Move it here, that's still 0. Move it here, that's 7. So now I have 7.0, but that doesn't matter. I can just write 7. And since I moved it 3 spots this way, I'm moving from a smaller number to a bigger number. So I need a negative exponent in this case. So it'll be 7 times 10 to the negative 3. Another way to think of this, if you like kind of doing it the first way I did in the last problem, oh, that's not a 0 there. Okay. Again, I'm seeing I'm really changing this 3 spots. So that means it's 1,000, but since I'm making the number, I had a smaller number originally, I'm really dividing by 1,000 times 7. Then remember those pesky negative exponents that we talked about? So this is really 1 over 10 cubed. And since I don't like a fraction as my power over here, oh, sorry, you guys are probably not being able to see that very well. This would be, if I move it back to the top, because I can have negative exponents here, 10 to the negative 3. Now I prefer doing it this first way, but again, either way is fine with me, whatever it takes for you to think about that. Okay. So I'm going to give you guys this problem, I'm going to let you try it. So if I give you 856.2, what is that going to equal in scientific notation? So go ahead and pause your video for a second and try that one on your own. I'm going to keep going. So again, I would say I'm moving this decimal, that's 85, that doesn't work. Move it another place, that's 8, so that's good. And since I made a bigger number smaller, I'm going to have 8.562 times 10. I moved 2 places, so that's positive because I made a bigger number smaller. So I want to make sure when I redid the problem, I would move it 2 back this way. And then one more example that you guys can pause and work on for a second here. And I would be moving this 2 this way because the first jump gives me 0. The second jump gives me 6. So I have 6.10 to the I moved 2 places. But since I moved this direction, I'm making a smaller number bigger, so I have a negative exponent. And another way to think of it too is when I move this back, I'm moving towards the negative direction, so that's why I need a negative exponent. Okay. All right, flip my page over here. Remember, if you need to pause at any time, you can do so. And now let's talk about writing in standard form. So now if I give you scientific notation, I want you to be able to write it in the normal form. So if I give you 7.1 times 10 cubed, I would say, well, it's a positive, so I want to make my number bigger. So I have 7.1 and moving it 1, 2, 3 decimal spots. So this is my new decimal. Wherever I see some empty humps, that's zeros now. So I have 7,100. That's my final answer there. So if I have to write it in standard form, I move it that many places, either in the positive direction or in the negative direction, which is my next example for you. Okay. So if I look at the example 0, I'm sorry, read my example wrong. So 8.12 times 10 to the negative 3. Again, this is a negative number here, so I'm going to move it towards the negative direction. So 8.12, I'm moving it 1, 2, 3 places to the left. Where I see those blank spots, I'm going to put zeros. So I have 0.000812. That's my decimal. So that's written in standard form. That's a regular number there for you. Okay. So here's your exit slip. Remember when you took notes through this whole thing, I need to be able to see the warm-up that you did. That's 4 points. And I need to be able to see the notes. That's a point. And then I need to see the exit slip. Okay. So please write this in scientific notation for me. And then write 3.2635 times 10 to the 5th in standard form, which is what we just did. Okay. Please, if you have any questions, let me know. Please go ahead and pause that video and work on that. And then your homework problems are on page 66, number 1 through 11 odd. Have a great night. We'll see you tomorrow. Bye.